I guess today we're going to continue from the place where we left yesterday. We were doing this question and we got stuck. The way I was approaching was a little unnecessarily complex. I mean, it was fine, but for some reason it did not work on code. So, first we're going to try that. If it doesn't work out, then we're going to think of something else. Okay. So, what we're doing is suppose this is an array and we were to find every x and delete it. But this is where I went wrong. I was approaching this as an array. I was not approaching this as a string. So given a string, we have to eliminate all the x's and combine them back together. Like we can't have space in between them. So first what I was doing that, and yeah, of course we have to do this recursively. So first what I was doing that, I would check for this. If this is x, if this is not x, I would have eliminated it. Sorry, I would have kept it and I would have run for the whole array and get the array without all the excess and then combine with this and then give it back if it were not x, and if it were x I would not combine with this, I would just simply return this. So if we go on coding for like that, first we write the function def remove. For now we're not just going to remove x, we're just going to remove any object that is given to us, and later in the input we can specify the x to be x. Remove object. So first we're going to look at the base case. The base case is either when it's 1 or 0. Let's take it to be 0 because handling 0 is much easier. I don't know why yesterday I was not doing it, but okay, let's see. So if length of we'll have to send some objects over here also. Let x be the object and not exactly the x string. If length of the list is equal to 0, so what we're gonna do is we're just gonna return the array itself. Now we're going to call for the rest of the array, leaving the first one behind. So and save it on a list called L2 save. And the array we're going to choose is going to be 1 2, the rest of them. Why is it showing any error? L2 is such okay, it's not being used. Now if L of 0 is equal to x, we're going to return only the L2 list. Else we're going to return L of 0 plus the L2 list. I'm going to write the driver code. So the input, it's given that input format is a string. So we're going to take input in the list str x rather n for n in input. Now, since in the question they have not specified that the input is going to be space separated or not, I'm going to assume it's going to be space separated for the sake of our convenience. Otherwise, we can also take strings separately, running a while loop. Let's just say it's separated. And next we're going to specify that specific input, right? So it's here in the question, it's particularly x. So we will pass down x later in the question. So we're going to run the code, print. We'll simply print the list first, and then we'll see if it's required. Then we'll put it again, like the question requires. We're going to print rem object l comma x. Okay, here x is supposed to be string object. Why was this an issue? Or acha, opt. There's something wrong. Oh, I was trying to concatenate this, right? If I remember correctly, we could do that, right? Like L equals to. Hmm, this is not happening. So how do we do that? Why? It's working, but let's check the internet. Maybe. Okay. We can simply add, right? So we don't have to do this all stuff. All right. A basic question is solved here. Now we're just going to store this. Rather, setting CV. All right. Now we're going to fix this. We were taking input in this. So we're going to learn how to split that string and convert into an array. I think if we just take an input, how would we know that each letter is? See, this is the issue. I don't want it like this. I want a whole complete string. They're using this same split function. I don't want to use it like that. Okay, list one equals to this. Hmm, let's try this. Seems interesting. Forward. So first we have to define it. Okay. My bad, my bad. Hmm. I mean, this is doing its job. How's it doing? What does this mean? I mean, starting is default by 0, ending at 0. How does it work like this? I don't understand. Okay, let's try to understand what's happening over here. We're going to create a string L equals 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, 8. All right. We're going to print L 0. Exactly, it's supposed to be an empty string. Like if we make L equals to string and string equals, let's say that. How is this assigning? I am unable to understand how is this working. Come on, man, I don't need all this sign up shit. Don't give me that. Let's try this. Hmm. How is this working? I'm not able to get it really. I mean, it's happening, but why is it happening? See, the last two were left out. Okay, let's try to figure this out. This question is confusing us. I mean, it's creating such scenarios. Even yesterday, we were unable to answer so many basic things, and it's hilarious how messed up it is, even being so easy. I don't know if I can handle it, the tough ones. Why is it happening like that? So, file new, don't save. Yeah. So we have an array, and we are saying that, okay, first let's try to print like this. And it's supposed to print all the elements. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, right. So I think this is a function And if I just remove this, even then it's running similarly. How is this even working, bro? Let's check. Slicing operator, okay. Yeah, I know that, but how is it working? Like, what's the coding behind it? What? How is it working? Tell me. We can change item like this. Okay, we're allowed to do this. I remember this. But I still can't seem to understand how is this working. So it's gonna take this string and replace it till it's filled. 1, 2, 3, 4, 5, 6, 6 till here, and then 7, 8, -2. Like, suppose we had only, oh, we did like this. Will it add on to that? See, it's adding on. The string is adding on. It's not replacing. It's not popping and replacing. It's not overwriting. It's adding on to that. Like if you want to add on everything. Acha, if we had to do it from like 0 to 4, rather, 5, 3, 3, 3, 3, my bad. Will overwrite everything. But if I write here minus 4, it will add. Okay, guys, we made a discovery that if we do like this, we're going to add, and if we remove the minus, we're going to replace. Wow, never knew that. Never saw that coming actually. I love to play around like this. All right, check this out. So when I did -1, we had some note like this. But if we did -1, the last part was not included, but everything else was in the end. It's appending, sort of. It's not effective, but yeah, it's working. But what's effective is we can make a string out of, and we can make an array out of a string like this. Nice. So this question here is done. Yeah, we don't need it. This question here is done. Let's move on with another one. Oh, wait, I have to save it. I save as. Practice. Just a second. Yeah, this is the question. Given a string s, consecutive duplicates has to be removed. So the question is like this. But I'd like to see some test cases. What if what if it's like this? Suppose x. So what do we remove this x as well? But it's saying only consecutive duplicates. So like if this is there. All right. So here's what I think I'm gonna do. I'm gonna take the first element and I'm going to assume the array that I'm going to uh, get from here. The first element of this array is not equal to this. Yeah, these both are not going to be same. Like suppose if we have x over here and some array coming from here, we're going to make sure that L of 0 is not equal to x. Rather, the original array is like this is L2 and this is L1 0. If this is true, we're going to remove this part and check again. But then this is going to cause us some problems. Like if we remove this part and check again for this whole system, then again it's going to check and check it. Okay, we're going to assume that it's not the same. It is already sorted and everything behind is sorted. So a good part about recursion is we don't have to worry about all this stuff. So we get an array. We're going to call recursion on this part. And we're going to assume that everything over here is fixed. We only have to worry about this part and the first part of the returned array. If this is not equal to this, we're going to remove this. We're going to return this. Yeah, this is how I will approach. Also have another approach. We will talk about it later. So first we're going to define the function. So def rem duplicates. We're going to give it an array, and then the base case is going to be like if length of this is equal to 0, then we're going to return the empty array. Then we're going to call for the rest of array excluding the first element. So, and we'll store it in L2. And I like there's a way I can avoid it, but for now let's just go with L2. We're just going to use a little more memory. It's not efficient, however, because you're doubling the memory usage unnecessarily, which can be avoided, but hey, no rules. Sorry. Here we go. And later we're going to check with if L of 0 is equal to L of 0, L2 of 0, return L2 of 0, L2 rather, yeah. Else we're going to return L of L2. If I'm not wrong, 0 1 will print only one, right? Yeah, only one. Let's write the driver code and quickly check it out. So we're going to take the input rather string is equals to input. I'm going to store it in the array. So this will have to define it, of course, and store it in the array. Then we will call it and we will print it in rem L. ZXX CVBB PN VVC. Okay. Okay, so the problem with this is if we return L, so when we left with this, there's nothing here. We call it again, there's again nothing here. So the two strings whose 0 is actually equal, since it's no, it's not that. And this line is being repeated multiple times. The recursion is exceeding the memory. Why would that be? Yeah. So we're going to take another test case like if or length is equal to 1 also, like it's not over the times when it's left. That's nice. Okay, so we have successfully deleted all that. There should be a way that I think I can actually handle string as L itself. I don't have to treat it like an array. What if I just saying, maybe it won't work. I don't know. I've never tried it before. Maybe I did. It was way long back. What did I do? All right. So we didn't have to actually do that in previous question, and it works simply fine for simple strings. Yeah. So this was an easy one. Okay. The second approach I was thinking in this question that I told you about is like we have string, we have its elements. So like if this and okay, I don't actually remember that anymore. Just give me a minute, I'll think about it. Uh, Holy shit, I don't remember anything anymore. Uh, what is this? Like if I this. Mhm. Uh, okay. Suppose we have a string which has some duplicate over here, here, and here, here, like that. Yeah. What I'm going to do is I will just check, but then it's the same as before if I pick these two and then check and think it's all sorted. Hmm. I suddenly forgot. How is that even possible? Anyways, moving on. We're going to save it. Desktop practice 7. Okay, this is a simple question. So we've heard about word sort, right? What is word sort and how it occurs, like how it's supposed to function, and it is an important sorting method. I'll tell you how it works. So we have an array of unsorted. Yeah, so it's an unsorted array. Of course, we're going to assume the numbers for now are positive. We can also put in negative numbers. It's going to work because it's based on simple comparisons and breaking up the problem. So, divide and conquer, in which we just simply divide the problem. So what we're going to do is we're going to pick a middle point, maybe this or this, whatever seems right to you. So we're going to pick it like here. We're going to bracket. We're going to say that you sort me this, and recursion 2 you sort me this. I'm going to assume that you're going to sort me this, and what my job is to combine them in a way that we don't have an issue. Like when I get these and these and I put them, so like it's like 1, 3, 4, 7, and this is 2, 1, sorry, 1, 2, 5, 9. This thing. So the way I'm supposed to merge them is 1 and 1. Like I'm gonna compare this one and then this one. I'll see that though both are equal, so I'm gonna take from the right one. You can take from the left one, it's all the same. So I'm going to take from the right one and I'm going to write it over here. I'm going to move it. Now we see 2 is greater, so I'm gonna write from here 1. Now I'm going to move it. Now we see 3 is greater than 2, then we're going to write 2. Similarly, we're going to write 3, then we'll have to compare with 4 and 5, and then we'll see that 4 is smaller, and then we'll write it over here, and then we still be at 5, and then we compare with 7, we see that 5 is smaller, then we write 7, and then we write 9. So this is how we're going to merge it. So we're going to assume that sorting is done over here, sorting is done over here, and now what is going to be our base case? Base case is going to be when it's this or none, there is nothing left. So first we need to write a code for merging. Given two sorted arrays, we have to merge them. Second code is going to be sorting them. We'll talk about it later. First, our priority is merging. So merging function def merge. We're going to pass two arrays L1, L2. We're going to assume that L1 and L2 are already sorted. Okay, and this is going to be an iterative program. I'm not going to write it recursively. I mean, there's a way you can write it recursively, but that's unnecessary. So What we're going to do is we're going to move pointer, like we're going to first assign the pointer on I equals to j equals to 0. Now this I and this is j over here. I'll clean it up for you. This is array 1, this is array 2, this is array 3 where we're going to save. Although there is a way in which you don't actually have to save it on third array, you can overwrite it in a smart manner, but I'll not do it right now. I'll do it someday later. So initially I is over here and j is over here. We're going to move it, right? So initially I and j are going to be 0 while. So while I plus, well, I plus j. So how long do we run? Suppose we run out of this. Do we stop over here or do we stop over here? We're going to stop when I plus j is greater than the length of the array. Because length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? But arrays this move like 0, 1, 2, 3, and 4. And this is going to be at max 0, 1, 2, and 3, and 4. So it's going to be add. So we have to write plus 2. I went so I plus j plus 2 should be greater than equal to the length of both arrays added together. Or we can do is they both have to be like the ending. You can also write it like this. While I is not equal to length of L1 minus 1 and j is not equal to length of L2 minus 1. Okay, so what I'm saying is जब तक until when this is not equal to, like here it is 5, length is 5, so then minus 1 is 4, and j is not equal to 4. Until then, like until both are equal to 4, we have to move. So first we're going to do is we're going to compare, right? If the first case is I is greater, j is smaller. If L1 I is greater, let's keep it also equal to, because there are going to be cases when the numbers are repeated. Equal to L2 j. What we are supposed to do, we're going to append, we're going to make an array. Yeah, L dot append L of j, right? I is going to stay there, j is going to move by 1. Now we compared this. we saw this I is greater, so J has to move. Now J is here. Now since J has come over here, we compared. We're going to see a second case. Else, see, L. Yeah. There's also a way like you don't actually have to write elif. We can write straight away if, but like there are cases like when you have to write else, the else won't apply for this. It will only apply for the latest if. So if you don't want that confusion, you should write elif. Elif L1 of I is less than L2 of J, rather J of L2. What am I saying? We got to append L dot append yeah L of, and then what we're going to do, we're going to append I, we're going to increment I. Now that we have gone to two cases, there is a third case. Imagine I comes here and J stays here. Wait. I comes all the way here. This is I, sorry. Yeah. And J stays here. Now what? Are we going to just ignore all these? No, right? We're going to move forward. So there are two more cases. If I is 0 and J is left and J is 0, like there is no J left and only I is left. So first we're going to write for I. When I has reached the end first. If I is equal to length of L1 minus 1. Now since we have written this condition already over here, and we know it's going to stop if J comes over here, we don't actually have to write over here as well. So we're going to add it until rather one by one instead of running a loop into loop. Or maybe we can do that because the very moment, yeah, we can write a loop itself while J is not equal to length of L2 minus 1. L dot append L of J, J equals to 1. So it's going to end up here. It's not going to check for all these cases. It's going to save us some time. Sort of, yeah. I mean, it won't check for this. It won't check for this. We'll see. We'll see. And we're going to write the same for J as well. So we're going to need array, right? L equals to x1 dot net. We will try the merge code. Print merge. Let's say L L2. Let's assume because yeah, it doesn't matter because this is going to terminate within this loop. But if you want, you can for safety write it y over here. I don't like to use multiple variables because it occupies memory. But however, it's your wish. If you want to do it, you can do it. Let's test it out. So 1 space 2 space 3 space 4 space 6 space 7 space 8. This should be 2 space 3 space 5 space 6 space 9. Okay, index out of range. How did it get out of range? So the length was 1, 2, 3, 4, 5, 6, 7. And here length was 5. So first, in first case, we can see that I is smaller than 2, then I is appended. This case, and I is moved forward. I is greater than and or equal to this. So J gets appended and J moves forward. J is here, I is here. Now we compare this. I gets appended, I moves forward, J moves forward. Or into this, I is not still not a less than. Oh, okay, let's try it like this. First mistake found. You know what? I want to move this out, this file. So what changes that I made were, first of all, we have to make sure that this and this are both less than the length of the given array. And now there's going to be only one case. Either it's bigger or equal or it's not. Maybe it should work now. Things still range. How's it out of range? Oh my god, this is so bad of me. Couldn't figure that out. That's such a shame of me, man. Alright, this is working. Oh, no, 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 it's not working. See, here's the problem. For some reason, there is a 4 over here. Why is there a 4 over here? Why is there a 4 over here? Wait. What? Of course. Now we're missing out on 7 and 8. It's not equal to because we are not going to count it out, right? I'm making so many silly mistakes. This is what happens, guys, when you don't code for a year or so. You forget everything. You start making mistakes, you miss out on basic things. Yeah, of course. We have to count the last one as well. That's why it was happening. Now we have to write a code for hash. Um, the code was for what? Sorting. Sorting. If not sort L. It's going to take a L. Come on. Yeah. So the base case was if length of L is to 0 or length of L is equal to 1, return L itself. We can't do much about it. If not, we're going to L1 equals to let us M be the point, like P be the point where we're going to divide it. So point equals to len of L divided by 2. We're going to take how do we do that? Maybe it's divided by 2. Yeah. Now L1 equals to L point, L2 equals to L point. Now we're going to return a list which is merge of L1 comma L2. Oh wait, we call the wrong function. We have to terminate it. Now there's a problem. There's a problem, guys. Guys, there's a problem. Oh yeah, I forgot to call merge sort on it. Sorry. Yeah, now it looks fine. Silly me. 1 1 2 2 2 3 3 3 3. Okay, at least the elements, the array size is same, the number of elements is same. Finally, our merge sort is working, guys. Holy shit, dude. Took me a lot of a time to do this. Took me around 20 minutes. Wow, that's that's a lot. We're going to save this as that is All right, let's get going. Mhm. Of course, I have to put it in this way. I need to write things to input. It doesn't matter what kind of input they put. Let them put anything. So the next question is, what was the next question? Where is it? Quick sort. Yeah, this one. All right. Okay, guys, I'll be back in just 5 minutes. I need a short break. I'll be back in 5 minutes, and I promise by tomorrow I will make every overlay and all. I will make it perfectly fine so that you see the welcome screen. You see everything. The point being, all right. BRB. Yeah, guys, I'm back. Uh, so what we're gonna do is, अभी क्या करना है? Quick sort करना है. So in quick sort, we have an array. Let's say 6, 1, 3, 9, 8, 4, 7. In quick sort, what we do is we find the supposed location of 6, and when we put it over there, we make sure the left side of 6 is having all the numbers shorter than 6, and right side of 6 is having all the numbers bigger than 6. For example, in this situation, we see 1, 4, and 3. These three are numbers which are shorter than it, right? So it's supposedly like 1, 3, 4, and 6. It's supposed to be here in place of 9. So we're going to do something such that 1, 2, 3, 5, 6. Such that 6 comes over here, and like let's say 1, 4, 3, for some reason it's unsorted over here, and 9, 8, 7, it's unsorted over here. 6 reached its position, and somehow these guys are smaller than 6, these guys are bigger than 6. And what we're going to do is we're going to tell recursion that what I did just right now, you're supposed to do it over here, and we're supposed to do it over here, and return me the correct answer, which is already sorted. And then I'm going to add it, make it a bigger array, like I'm going to join it together, and I'm going to return it, right? So yeah, let's get started. So now we know that we just have to move 6 into its position and make sure that every element shorter than it comes to the left. So how do we do that? First we're going to write, so it's like we're making a partition, right? So first we'll write the partition code. Def partition. We will be given an array, so list array. Let it be a, because why not? L be the length of a, because we'll be using it again and again, so why not? And let initially p equals to 0. P is going to be the variable I'm going to use for partition, the location of partition rather. So for I in range, from where to where? From 1 to L, because we're just going to pick initially it's 0, right, the first element itself. And in that, if a of I is less than equal to a of 0, what we're going to do is we're going to increment rp, and then we will swap it. A of 0, um, yeah, a of p. What is wrong with it? Wait a second, guys. Just a second. Yeah, guys, I'm sorry. I'm sorry. I had some issue in my PC. Yeah. So we're going to swap it. Now we did it for like making sure that we reach its position. Now we're going to write initial. I'd rather do it like this. This is gonna look funny, okay? Don't laugh at me, but it's gonna work. Trust me. Then we're going to return 3. Next, we will write the code for partition, this sorting. No, 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 no. Okay, guys, I'm just gonna hang it over here only. We'll code it tomorrow. I have to go. I'm not feeling well also. So, yeah. Thank you so much for watching. Thank you so much for coming. Thank you for the likes. And I'll see you tomorrow. Bye, guys.